think we're going to start. Okay, we're going to start, and my first theme that I wanted to do with you is vectors. Jason, wat gaan nou hier aan? Okay, let me just get this. Okay, we're going to start just now. Okay, we're just struggling. The board is going to turn the pages just now. Ek hierdie pen wanneer dit help nie. Oh, thank you. Okay, I need you to switch off your mics. Okay, when you have a question, you switch it on and then you can ask it because everybody can hear you at this stage. So please just do that. We're going to start with vectors. Now, what I left here for this is just the definitions that you need to remember. You must know what's the definition of a vector, what is a definition of a scalar. Remember, a vector has both magnitude as well as direction. Okay. Magnitude as well as direction, and a scalar is a quantity that only has magnitude. So a vector will be a force because there's a force at a certain amount of newtons as well as a direction that it's going to go in. And let's say a scalar is, there's always a difference between velocity and a speed. Speed is a scalar while velocity is a vector. Okay, and acceleration is a vector. Now, the moment when you get a vector, when they talk about a vector, you must have an answer with a unit as well as a direction that you're going to work with. Okay, so that's the difference between vectors and scalars. Now, I wanted to just shorten this lesson so that you can see what is the type of sums that you can expect in this question. Now, that will be normally the first question that you're going to answer after the multiple choice in paper 1 for grade 11. Now, the first type, and I named it type A, is where you have a substance that on a flat surface or substance, anything I tried to show you there, a block or maybe a block that is standing still or object on the floor or so, and they just want you on an axis, they just want you to work out the resultant force. So normally the question will be, they can break it up into parts. I can say work out the X and the Y component for each of these forces, or they can just say calculate the resultant force at the end. So the main question that they can ask, the after all question, is to calculate the resultant force. Now, when you get a type A sum like this, the object is standing on a surface area and they want you to work out the resultant force, you start with the first one. So let's start with force 1. Okay, now of force 1, what I'm going to do is I'm going to work out force 1's X and force 1's Y component. So of each force, I'm going to work out the X and Y component. Now, when I want to work out the X component, I have to remember that I use the equation F cos theta. Okay, that's how we work out the X component of a certain substance. Or if I want to work out the Y component, then I will use the force sine theta. Okay, so if I look at F1, the force that I'm going to get, let's make this one purple there. The force that I have is 120 newtons. So I'm going to put in 120 cos, and then it's important that this angle that I'm going to put in here must be the angle. Now, if you have an X and a Y axis that you can see it there, that's the Y and the X axis. The angle that you put in there must be one of the bow tie angles. So it must be one of that angle. So the angle that is making with the x-axis here, that is the angle that I have to put in when I'm going to work out the x and the y component of each one. Now, the total angle that we have here is 70 degrees. So I put in 120, that's the magnitude of the force, cos 70. And when I work that out with my calculator, I got 41,042. I tried to keep this answer to 3 or 4 decimal places. Now, what I want you to do is to work it out with your calculator as well, just to make sure that you get the same answer. Now, in this question, I'm going to say this is newtons, and then the direction for this one, the x component, is going to be to the right. Because if I look at the purple one there, the x and the y component that I'm looking at that's the x component of that one, and that's the y component. So the x component is to the right. So I'm just going to write there for myself. I must remember that this one that's the magnitude to the right. When I look at the y component for this one, I use the same. So it's 120 sine, and then the angle is 70. So make sure that you understand what angle you need to use, because if you use the wrong angle, the whole thing is wrong. Now, I got an answer of 112,763 newtons. And when I look at this one, you will see that the y component is upwards. So let's just put that in green as well. That's the y component. So that is of F1. The next one that I'm going to do is F2. Now, I'm going to do F2 in blue. Now, for F2, I'm going to do the same. I'm going to have the x component, and I'm going to work out the y component, because we want to get the resultant force of all of these. Now, when I look at this angle, it's going to be the angle there that it makes with the x-axis. And on my picture, it says that the angle is 40 degrees. So I'm going to have x cos theta equals to the 80 cos, and then it's 40. Okay. And when I work that out, 80 cos 40, I got 61,284 newtons. And again, the x component is to the right, as you can see here. That's the x component, so that would be to the right. And the y component, which is going to be f sine theta. So I'm going to get 80 sine 40. Okay. And 80 sine 40 on my calculator gives me an answer of 51,423 newtons. And again, it is to the right, as you can see it there. Upwards, now, up. All right. The last one is F3. Okay, now let's look at F3. F3 is this one. It's 150 newtons. Okay, so when I look at that one, I'm going to say for F3, I'm going to have a Fx and a Fy. And when I work out the Fx is F cos theta. So when I substitute in, it's going to be 150 cos. And the angle that I use is the angle with the x-axis. Now look at this angle. So it's going to be this one that makes an angle with the x-axis. So there's the x and there's the y-axis. So I'm going to substitute in 35 degrees. When I work this out with my calculator, I'm going to get an answer of 122,873 newtons. And I'm going to say that this x component is going to be to the left, as you can see it there. All right. Then the y component, I'm going to say f sine theta. So the y component, I will always work out with sine theta, and the x component, I will always work out with cos theta. So I'm going to substitute in 150 sine, and the angle that I use is 35 degrees. So when I work this out with my calculator, I got an answer for this one as 86,036 Newton. And then this one will be also, the y component is upwards, because this one is going, that's the y component upwards, showing upwards. Okay. So we can say that this is actually step one. So step one in this sum is to go and work out all the x and y components of all these vector quantities, or the forces that is working out on this object. So that would be step one that we do. Step two is to add all the x components and to add all the y components. Now let's look at step two. Now for step two, we're going to do the following. I'm going to say fx total. That's what I'm going to work out. Now that's why it was important to write down to the right or to the left for the x and the y component, or upwards or downwards. Because I'm going to choose, and you can choose your direction, but I'm going to choose to the right as positive. So what I'm going to have here is I'm going to start with F1, which is positive. So I can say F1 and I choose to the right as positive. F2's x component is also to the right. So I can say plus x, F2's x component, and then F3's x component is to the left. So then I'm going to minus that one. That is the x's of each one. Okay. So F1, when we look at F1, the answer is 41,042. So I substitute in 41,042 plus x2 is 61,284, and then minus 122,873. Okay, so this is actually all the x's adding together, but if it goes in the opposite direction, I show it by using a minus. Now when I add everything up, I get a negative answer, which is minus 20,547 newtons. Now, when you get a negative answer, it actually is not negative, it just shows the direction. And then we can say, therefore, Fx total is 20,547 newtons to the left. Can you see that? So I put it into the left then. Right, now the next thing that I'm going to do is I'm going to add all the y's. Now Fy total, but all the y's is going to go upwards. You can go and check there. So F1's y is upwards, if you look at that one. F2's y is also upwards, and F3's y is also upwards. Can you see that? So I'm going to, because all of them are going in the positive y direction, I can say Fy of 1 plus Fy of 2 plus Fy of 3. So I can just add everything and then I will get a total answer which is upwards. So the total that I'm going to put in is 112,763 plus 51,423 plus 86,036. When I add everything, I'm going to get an answer of 250,222 newtons upwards. Okay, so that's the total of the y upwards. Okay, so step one, what was step one? To work out all the x and the y components of each force that I have on my sketch. Step two is to add all the x's and to add all the y's, and I have to use that by looking at the direction in which it is. Step three. For step three, it is easier to go and draw the vector diagram that we have. So the total fx is to the left. So it will be aligned to the left. And the total Fy's is upwards, as you can see it there. But the net force, because that's what they want us to work out, is the net force at the end. is going to be somewhere here in the middle. That would be your F resultant or F net. It doesn't matter, both of the terms is going to be correct. Now, if I substitute in for the Y is 250,222, and for the X, it is 20,547, 20,547. Now I can use Pythagoras to work out the F net. Okay, so the next step that I'm going to do is I use Pythagoras. So I'm going to say F net or F resultant square equals to fx total square plus fy total square. I use Pythagoras. Now fx, we all know, is the 20,547 square, and the y is the 250,222 square. That would be F resultant or F net square. Now, when I want to get the squares away, I have to square root the whole thing. So what I'm going to do is I'm going to get a F resultant or a net resultant force that has a magnitude of 251,064 newtons. Okay, so that would be the magnitude. All right. But now we just talked about a vector and a scalar. A vector has a magnitude, that's what I worked out, and it has a direction. So the final direction that I'm going to use is then this angle. Remember, it's always the angle with the x-axis. Or as I showed you at the beginning, when we have the x and the y-axis, it will be the bow tie angle. So always the angle between that, the x-axis, and your force that we're going to have. Okay, so that angle, this is the angle that I need to work out. Now, if you always work out this angle, you can use tan. Okay, so you can just remember I have to use tan to work out that angle. So tan equals to opposite over adjacent. So when I write that, I'm going to say tan theta equals to opposite, which is the y component. So in this case, it is 250,222 divided by the x component, which is 20,547. Now on my calculator, I'm going to put in shift tan, and then there will be a bracket. So you say 250,222 divide 20,547, close the bracket, get your answer. So the angle that we're going to get for this one is going to be 85,31 newtons. But if you use this method, you must describe this angle. Now, there's a lot of ways that you can describe the angle, but I think the easier way is to say, this is the 85,31 degrees north, because, or above, let's say above the negative x-axis. Okay, this is what you're going to say. It's above the negative x-axis. So your final answer is F resultant is 251,064 newtons in the direction 85,31 degrees above the negative axis. Okay, now let's quickly check what was the steps. This I said is question type A that you can see there, where we have a substance and we have the forces that is working on this object, and they just want you to calculate the resultant or the net force. Step 1 will be for each force to work out the x and the y component. Step 2 will be to add all the x's and all the y's. Then step 3 will be to draw the diagram to show in which direction each one is so that you can work out your net force. Step 4 will be to use Pythagoras to work out the magnitude of the resultant force. And step 5 will be to work out the angle. Okay, so this is type 1. Normally we have 2 types of questions. This is type 1. Let's do another one that is almost the same. You will see this one I got out of an old exam paper. This is how it looks like. They say, the diagram below shows 2 forces A and B of equal magnitude which acts on the object as shown below. And then they say calculate the magnitude. So now they don't want you to use tan at the end. No, they just want you to work out the magnitude of the resultant force A and B, as you can see it there. Now let's follow the steps. Step 1 is for each force to work out the X and Y component. So F1, I'm going to work out Fx and Fy. So I'm going to say F cos theta, and then for the Y component, I always use F sine theta. So for, let's just name this A, okay, because I did this one as A. Now, I have 150 cos, but now the angle is the total angle from there to there, okay? So sometimes, let's just say, for instance, they didn't stop this line here. I just want to show you because this is where they can catch you out. Say, for instance, they didn't put this one in, okay? So this one just stopped there, okay? That was a 45 degrees angle. Then you had to add everything. Then you had to say 45 plus the 30 because you need to use the angle with the x-axis. Okay, that's how they can catch you out sometimes. Okay, but now they didn't try to catch us out. They said that this one in any case is an angle from there to the x-axis is 45, and that is the bow tie angle. Now, in any case, it's this angle that we use. So I can use the 45. Okay. When I put that in my calculator, I got an answer of 106,066 newtons. And then right there for yourself to remember that it is to the right because we just work out the x component and that would be to the right. Okay. Yes. Oh. Okay. Ooh. Okay. Then the next one is 150 sine, and again 45. And then when we work that out, we get the same answer, 106,066 Newton. And this would be the Y component, which is upwards. So let's just write there, upwards. Okay.
Excuse me, ma'am.
Yes.
Can you please let me record my screen? They say I should ask the host to let me record because I want to record.
Okay, we are recording it, but I have the technician here with me.
Okay.
We are going to put it on YouTube, and we will give you you have the link also to open it. Okay, now
Okay.
he said
Thank
it's
you,
fine. Okay. Then number 2, the second one that I'm going to do, or force B, is going to be FB, where we have Fx plus Fy. And now we're going to say it's F cos theta. And again, we have F sine theta for the X and the Y. The force again is 150 because now we're looking at B. Now, the magnitude of the force again is 150. We use cos. And now the angle that we use is the 30. 150 cos 30. And we use the same 150 sine 30. Okay. And now when we work this out, we're going to get an answer for this one as 129,904 newtons. And the other one is 75 newtons. Again, let me just get the green one. Again, the fx is to the right and the fy is upwards. That was step 1. Step 2 that we're going to do is to add all the x's and all the y's. So step 2, I'm going to say fx total. Now both is to the right. So I'm going to have 106,066 plus 129,904. And then I get a total, if I add everything up to the right, as 235,97 newtons to the right. Okay, again, I add up for the next one all the y's. So Fy total, it's going to be, both of them are upwards, so I can say 106,066 plus, and then the other one is 75. So the total that I get for this two when I add it up is 181,066 newtons, and that would be upwards. Okay, that was step 2 where I add all the x's and all the y's. Step 3, you have to remember, is to draw the x and y axis. So it's to the right and upwards. So fx total is to the right, which is 235,97, and the y is upwards, which is 181,066. The net or resultant force that we have to work out is going to be this one that I show you here. Now, step 4 is to use Pythagoras. Okay, so when I use Pythagoras, I'm going to say F resultant square equals 2, and now I'm going to have the Fx total square plus the Fy total square. So when I substitute it in, I'm going to say F resultant equals to 1. Now let's just fill it in correctly there so that the x is at the x and the y is at the y. So the x is then the 235, 235,79 square plus the 181,066 to the power of 2. Okay. To get the square away, I use the square root. So the F resultant is going to give us an answer of, and then 297,434 newtons. Okay. Now, because I said you just have to work out the magnitude, this is where the sum is going to stop. But you will see, can you see how much marks? 8 marks for this. So 8 marks if you can just remember the steps. Say, for instance, they didn't say magnitude. They just say that you have to work out the resultant force. What is step 5? Step 5 will be to work out the angle. And when we work out the angle, we say tan theta equals 2. Now it's this angle that we use. Can you see this one? So this is the opposite equals to opposite over adjacent. So it means the y, which is 181,066 over the x, which is 235,97. And then you put in your calculator, shift tan, there will be a bracket, 181,066 divided by 235,97, close the bracket and equal. Okay, then you will get your answer for theta will be 37,5 degrees. Okay, but now we have to describe it. So we're going to say above the positive x-axis. All right, above the positive x-axis, and that would be your final answer. So this is type A that I have here. The next one that we're going to look at is type B. Okay. Now type B normally will be, I think that's the better one, type B. Type B will normally be an object that is attached to ropes and it's hanging still. The object is hanging still somewhere. It can be a block, a box, whatever, a picture, anything that you can see it here. Now it's attached there, let's say to the ceiling here, and then this is to the side. Let's say this is the wall and the ceiling then. What they can ask us, they would say, and the word that you're going to look at for type B is this forces are in equilibrium. So you need to use the forces that are in equilibrium. The moment when they say the word equilibrium or the system is hanging still, nothing is moving, then what you're going to do is you must remember, because the system is in equilibrium, I can use a triangle to solve the problem. Okay, now for this type, they say for the following diagram, and this is also steps that you can use. Draw a forces diagram, then you draw a vector diagram, and then you can work out any one of those forces that you need to get. Okay, so calculate the unknown forces. Now a forces diagram is the one that I'm going to show you first. Forces diagram or a free body diagram. So what I have is, I have the box, the block, which is 500 grams. Okay, the forces that are working on this block is number one, the weight of the block. You can use W, the weight, or you can use the gravitation force of the block, Fg. Now we all know Fg is equal to m times g, which is the same. Weight or gravitation force is the same thing. The next one that I have is T2. So that's a tension in rope T. Now, if this rope, can you see that is it? On my picture, this must be parallel. So if I draw it parallel to that one, it must be parallel to this one. Can you see these two lines are parallel to each other? So that is T2. And the other force that I have is T1. So let's quickly look at T1 in this direction. So parallel to T1, it will be this one. So that would be the forces, or sometimes the free body diagram. Forces diagram normally is from a block, but you can draw it from a dot just for yourself here. Because the system is in equilibrium, I can draw from this a triangle of forces. Okay, so now I can say, right, I have, and I like to start with the weight. So I have the weight that goes in this direction. Then what else do I have? I have T1 in that direction, and I have T2 in that direction. Now, the main thing that you need to remember is that if T2 is like that, then T2 must go in that direction again. So that's T2. T1 is this one, again parallel, and then this would be the weight. Okay. Now you must be able to put in the angles. Now, the only angle that we have is this angle. That's this angle that they gave us. Okay. Now, if I do this, I just put in the stipple lines there. Then it's a 90-degree triangle. Can you see that? So this angle here is 30. So this angle is going to be 60. So when I look at this, I can see that this one that makes an angle with the x-axis, this one is 30. Can you see that? This one here is going to be a 90-degree triangle, and then this one is going to be a 60. So if I have the triangle, I can draw the triangle, I can put in the forces, and I can put in the angles, then I can solve it. And the easier way to solve this triangle is to use the sine rule. Okay. Now, the only thing that we still need is one of these forces. We can only solve a triangle if we have at least one force. And the one that we have is the weight, because they give us the mass of this block. They say the mass of this block is 500 grams. So when I want to work out the weight of the block, I'm going to say it's m times g, because it's the same as if g equals to m times g. Now in paper 1, the mass must be in kilograms. Now this block's mass is in grams. So I have to divide it by 1,000 to get kilograms. So the mass that I'm going to put in my sum is 0.5 kilograms, because 500 grams give me 0.5 kilograms. Okay, times, then g will always be 9,8. That's a gravitation acceleration on Earth. I work out the weight of this block, which is 4,9 newtons. So it means that I have this one, 4,9 newtons. All right. Now I can solve the rest. Now let me just show you what I can do to solve the rest. I'm going to use the sine rule. I think that's the easier way. There is other ways that you may use, but I'm going to use the sine rule. Now, the sine rule, you must remember, this is the angle that we have. That's the weight. That's the side that we had. Now, the angle opposite of this side is 30. So when I write the sine rule, I'm going to say the weight, or W, that's what I call this force downwards, over sine 30. That's the angle just across that one, equals 2. And now I want, let's say we start with T1. T1 equals to sine, and now I have to use the angle that is across T1. Now when I look at that one, it means this is T1. I'm looking at that angle, the 60 degrees. Can you see? T1 is this one here. So the angle across that one is 60. So I'm going to put in here as 60. When I work it out, I can go and substitute in. I have the weight, which is 4,9. This one divides. I'm going to take it to the top. So times sine 60, and then over sine 30. And that will give me T1. Now, when I work out T1, you're going to get an answer for T1 as, let me just get my, there it is, 8, T1 equals to 8,49 newtons. So what you put in is 4.9 sine 60, and then you can say equal, and then that answer divided by sine 30 will give you T1, which is 8,49. The next one that I want to work out is T2. Okay, so still I'm going to use the weight. I can use T1 as well, but I'm going to use weight, sine, and the angle just opposite of the weight is then this one, which is the 30. And now I want to know what is T2. And this is T2, opposite of T2, the angle is 90 degrees. So then I say over sine 90. Okay, I could have used the normal sin trigonometry functions as well. But if we have a method and it's easier to stick with with this method, why not? Okay, the weight that we worked out is 4,9. So I say 4,9 times sine 90 divide by sine 30 equals to T2. So the answer that I got for T2 is going to be 9,8 newtons. And this is how I would solve this if they want any one of those forces or tension forces that we can use. Let's look at another example like this one. Another example that I have here is this one. The only thing that I want you to just add here is we're going to give a value for T1 and I'm going to say T1 equals to 100 Newton. Just add that. Again, what I'm going to do is, remember, they would say all these forces are in equilibrium, or this robot are hanging still, it's not moving. If it hangs still, it's not moving, then we can actually say that this forces are in equilibrium, and we can go and put it on the sides of a triangle, or draw a triangle of forces of this, all these forces that are in equilibrium. So the first thing that I'm going to draw is the forces diagram. Let's do a dot. I have the weight. Now that's the weight, but let's use it as T3. That's T3, because that's going to be exactly the same. The other one that I have is a T2, as you can see it there. And the other one that I have is T1. Okay. Now we must be careful, because this is the forces, or this is the angles that I give us. Okay. So when I have this, look at this, when these two lines are parallel to each other, it means this force is also 37. Okay. Angle. So this angle is 37. And if I complete it, this is a 90-degree triangle. So it means that 37, and this one will be 53. 90 minus 37 is 53. Same with this side. Let's look at this side for the angle. So again, we have this one. These two lines are parallel to each other. So it means that this angle is 53. So this angle is going to be 37. Okay. When I draw the triangle of forces for this one, I'm going to say, right, I have the weight downwards. Parallel to T2, I'm going to draw T2. And parallel to T1, I'm going to draw a line for T1. Can you see? The triangle is a closed triangle, and the arrow marks is actually anti-clockwise or clockwise. You will never have two arrow points together or so. Okay, so that's why this line, T1 and T1 of this one, must be parallel to each other. All right. Now I can go and put in the angles. Now, when I look at this one, you will see that the angle of T1, there's T1, and the vertical. So let's just draw this in yellow. So actually, this angle is going to be 53. Now, if this line, the yellow line, and this line is parallel, it means this angle is 53 in the triangle. Okay. And then when I look at this one, it is the T2. So let's look at T2, purple here. So I say this is purple. So with the straight Y there, this angle is 37. Now all the triangles, all the angles inside a triangle will give me a total of 180. So it means that this angle is going to be 90 degrees. And then they give us T1, they say it is 100 newtons. Okay, so we have to solve T2, and they want us to calculate the mass of the object. So this would be T3 that we're going to use to work out the mass of the object. Now let's start with T1. So I'm going to say, because I have T1, T1 over sine, and the angle opposite of T1 is going to be 37 degrees, equals to, and I want to know what is T2 over sine, and the angle opposite T2 is 53 degrees. Can you see that? So when I work it out, I have the value for T1. So it's going to be 100 times sine 53 divided by sine 37 equals to T2. So when I work this out, I got an answer for T2 as 99.94 newtons. Now, I'm going to try to work out T3 because from T3 I can work out the mass. So I'm going to start again. So I'm going to say T1 over sine 37 equals to T3, which is the weight, over, and the opposite angle is 90 degrees, sine 90. Okay. T1 is 100, so I can say 100 sine 90 divide by sine 37 equals to T3. So T3 is going to give us an answer in newtons of 166,16 Newton. But they ask me the mass, not the force. So T3 is actually the weight. Can you see that? So what I can do now is I can say weight, or T3, because that's the same thing, equals to m times g. So the weight is 166,16 equals to, I want the mass, and the gravitation acceleration is 9,8. So when I work out this mass, I'm going to get an answer of, so it's 166,16 divided by 9,8. 166.16 divided by 9.8 gives me an answer of the mass equals to 16,96 kilograms. Your answer is in kilogram because in paper 1 we are working with kilograms. Okay. The next one is example C that I have here. Calculate the mass of the object. So again, they want us to work out the mass of this object. Now, again, in the question, they would say that this object M is hanging still or is in equilibrium, and they just want us to work out the mass of the object. Now, what I will do is I will go and draw my triangle. So this is the weight that I'm going to use to work out the mass. This is Q parallel to Q. Can you see that? And this is P parallel to P in the picture given to us. Okay. Now, this is P with the vertical, so that is 30 degrees. And this one is going to be, if I look at that, 60 degrees. So this angle is 60. Again, we have a 90 degrees, not always going to be a 90-degree triangle. What they give us is either P or Q, Q is 7, that we can use. P or Q that we can use. It doesn't matter which one you choose to use now. Okay, so let's say I chose P, so I say P over sine, and the angle across P is 60 equals to, and I want the weight, sine, and the angle across the weight is 90. Okay, so now I say P is 3, so it's going to be 3 sine 90 divided by sine 60 equals to the weight. When we work that out, we get the weight as 2,91. Now, if I want to work out the mass, I say weight equals to m times g. 2,91 equals to the mass times 9,8. So now I say 2,91 divide by 9,8. Okay, so 2.91 divided by 9.8 gives me an answer of, the mass of this object is 0,3 if we round it off. 0,297. Okay, let's rather use 0,297 because on the paper they said we have to round off to a minimum of 2 decimal places. So it's 297. So we're going to rather round off then to 3 places than to leave it at 1 place, okay, after the comma. So that would be the answer of example C. Now what I have is an exercise. And this exercise is an old exam paper that we've got, that I got from my resources. So let's quickly see how they're going to ask it. They say an aeroplane makes an emergency landing on an international airport, Cape Town. The passenger leaves the plane by means of a slide that is 5 meters high and makes an angle of 20 degrees with the horizontal. So there immediately I can say this is 5 meters high. A constant resultant force of 150 Newton in working on the passengers parallel to the slope when they are sliding. Determine the vertical component of the force and the horizontal component of the force. This is just what they want us to work out. Now, vertical component, so that's type A. Vertical component is Fy, which is F sine theta. Okay, the force is 150, sine, the angle is 20. So we get 150 sine 20, and then we get an answer of 51,30 newtons. 51,30 newtons. And because it's the y-axis, in this case, the y-axis is going to be downwards. Okay, so remember, if we have the bow tie, it will be in that quadrant. Oh no, I'm lying to you now. It's not going to be in that quadrant. It's going to be in this quadrant here, this one. So it means that that's the y and that's the x component that we're looking at. So the y component is going to be downwards. Okay. And for the component, write down the direction for the component as well. For the x component, we use fx, which is f cos theta. So we substitute in 150 cos 20, and 150 cos 20 will give you an answer of 140,95 newtons, and this will be to the left. Okay, to the left. This is all that they ask. This whole question counted 4 marks, so that's easy. So if we want to work out the x and y components, we just have to remember that the y component is f sine theta, the x component is f cos theta. Right, the next question of this paper was the next one. Look at this one. They say 3 forces working on a point O, as indicated in the diagram, are in equilibrium. Equilibrium is the clue word. Determine the magnitude of the force W if W is the resultant of the 2 forces in the vertical direction. Okay, now we can go and draw the triangle of forces and then work it out. Or what we need to remember is that the y component of this force plus the y component of this force will give me the weight. Now let me just quickly show that to you. Now the one that I showed to you is the one where we have the triangle. So that's the weight, that's the one, and that's the other one. Now, okay. Now let's fill in. This one is 40 newtons. This one is 49 newtons. This one is the weight. They want us to work out the weight. All right. Now, when we look at this angle here is 45. So it means this angle is 45 degrees. And then this angle here is 30. So it means that this angle is 60 degrees. And then the last angle when we work it out will be 75 degrees. So when I work out the weight, I can say the weight over sine 75 equals 2, and now I can use any one of the two. Let's say I use the 49 over sine 60. When I work out the weight, I can say 49 times sine 75 degrees over sine 60. And then I'm going to get an answer when I work it out as 54,65 newtons. So that's one way to get the magnitude of the weight. Another way is to work out the y components of each. So I can say Fy equals to F sine theta. So this one is 49 sine 45. And for this one, I do the same. The y component is f sine theta. So I can use the 40 sine 30. When we work out both of this, we're going to get an answer. Sorry about this. We're going to get an answer of 49 sine 45. Answer is 34,648 newtons. And then the other one is 40 sine 30. Answer is 20. Because are going both in the same direction. If I add this to 34,64 plus the 20, you get the same answer, the 54,65. Okay. So the main thing that we need to remember is that all the forces that goes upwards, if the forces are in equilibrium, have the same magnitude as all the forces that goes downwards, as you can see it there. Right. The next one is more forces question, and that will forces I'm going to do tomorrow. I will handle that tomorrow. The next one is this one. Now, immediately you can see here, a man supported by two non-stretching ropes. So I will immediately see this as a type B question. Okay. Which component of the force in BC will balance in AB? And that would be the X component of BC, because this one is going to be equal to that one, same magnitude and direction. Okay. And then they say determine the maximum vertical component of BC when the force in the rope is 400. So they want the maximum vertical component if they give us this one for 400. Okay. What I will do is, because the forces are in equilibrium, draw your triangle, use your sine rule, and work it out then at the end. Okay. So when we draw the triangle, I'm quickly going to show you that because our time is actually up now almost. So it's the weight of this guy, the AB force, and the BC force, as you can see it there. Now I can go and put it in. This one is 400. This one is 90 degrees. And then this one is 60. Okay. So what I know is that this Y component is the same as the weight of this guy, because these forces are in equilibrium. Okay, so if I work out the Y component, I will have the weight of this person. Okay, so remember two types of question. The one is where I just have an object, forces working on the object, go and work out all the X and the Y components, add all the X's, add all the Y's, and then Pythagoras, and then you get your angle. Type 2 is where the forces are in equilibrium. Use the triangle, use the sine rule. I think the sine rule is more easier. I will see you tomorrow, the same time. Okay, 12:30 for tomorrow with the first lesson of forces. You must take care. Goodbye.